Hello and welcome back to the channel. In this video, we will be comparing the low threshold voltage and high threshold voltage transistors in VLSI. So we will compare the DC characteristics of the inverters that we will be designing using the low threshold voltage transistors and high threshold voltage transistors. We will be doing the simulations using Cadence Virtuoso. So let us explore how the variations in threshold voltage impact the switching behavior, power consumption, and performance. So we know that in VLSI designs, the transistors can have different threshold voltages. Basically, the threshold voltage means the input voltage that is required for the transistor to turn on or for the transistor to conduct. So the low threshold voltage transistors have a will turn on at obviously a lower voltage. It will make them faster, but there will be also more leakage currents. Hence the low threshold voltage devices are have the property of faster switching because they turn on at lower voltages. On the other hand, the HVT transistors will turn on at a higher voltage. So when we see the high threshold voltage devices, the switching will occur at a higher voltage. So they will typically have a lower leakage current, hence lower power dissipation. So modern designs use a multi-threshold voltage approach where the low threshold voltage devices are used only in critical parts, that is the parts that are critical for the speed of the system, because the low threshold voltage devices have higher speeds, so they are used only in critical parts because they are having the disadvantage of higher leakage current or high power dissipation. Hence they are not used in non-critical paths. In the next step, we will set up a DC simulation to analyze how the output voltage will change with respect to the input voltage. So you can see on the left hand side, I have made a CMOS inverter using low threshold voltage NMOS and PMOS, and on the right hand side I have designed a CMOS inverter using a high threshold voltage based NMOS and PMOS. So now we will do the DC analysis and plot the voltage transfer characteristics. All other parameters will be exactly the same for the two inverters, only we are using different threshold voltage based transistors. So you can see this is the voltage transfer characteristics for low threshold voltage based inverters. Now we will find out the switching point. The switching point is the voltage at which the output voltage is exactly equal to the input voltage. So we can zoom on the curves to find the exact voltage at which this switching will happen. That is very important. So when we zoom in, then we can see that the switching is happening at exactly 777 millivolts. Also we can find the current at this point is about 453 microamperes. So now we will compare these values with the values that we will get for the high threshold voltage inverters, and then we will make our conclusions. So we will repeat this exact DC simulation for the high threshold voltage based CMOS inverter as well. Remember, all other parameters will be exactly the same. So now we will plot the DC, we will do the DC analysis for this high threshold voltage CMOS inverters. So you can straight away notice there is some change in the shape of the voltage transfer characteristic curves. Also on the right hand side y axis you can see that the current values have reduced to a significantly lower level. We will find out the exact values in just a moment. First we will see the switching voltage at which this switching happens. So we can see that the switching is happening at 824 millivolts for the high threshold voltage based CMOS inverter, whereas for LVT this was 777 millivolt, but the current has reduced to 185 microampere. So when we compare the LVT based CMOS inverters then with the HVT based CMOS inverter, then we can say that the LVT based transistors enable faster transition but they come with higher leakage current and hence more dynamic power consumption, because the leakage current is more in the LVT compared to HVT, so the power dissipation will be more. On the other hand, the HVT transistors are more power efficient, but they switch at a higher input voltage also, and they may be introducing delays in our design because obviously the switching voltage increases. So the choice between HVT and LVT will depend on our design, whether we prioritize speed or efficiency. Hence, so now let us see the voltage transfer characteristic curves for low threshold voltage device and high threshold voltage devices in further detail. So first we will try to find out the threshold voltage for these devices. So you can see this is the current curve for the low threshold voltage device, this curve that you can see in pink. So we can see that the current starts to rise at about 0.2 volt. So we can see that the threshold voltage for this transistor is 0.2 volt, whereas this is the current curve for high threshold voltage device. So we can see that the current starts to rise at 0.4 volt. So we can say that the threshold voltage for this device is around 0.4 volt. Also we can see that this is the curve for the output voltage. So we can see for the low threshold voltage device, the output voltage starts to decrease from around 0.3 volt, whereas for high threshold voltage device we can see that the output voltage starts to decrease at about 0.5 volt. Also we can see that the current for the high threshold voltage device, the maximum current is around 180 microampere, whereas for the low threshold voltage device the maximum current is 450 microampere. So you can see that there is a jump in almost 3 times the current in low threshold voltage device. That is why there is a more leakage in the low threshold voltage device. Now we will try to merge these two plots in a single picture. So you can see that with the help of a software I have tried to merge these curves in a single image. So you can see that this is the current curve for low threshold voltage device, and this is the current curve for high threshold voltage device. So you can see that there is a shift towards the left for the low threshold voltage device. Also you can see that this is the output voltage curve for high threshold voltage device, and this is the output voltage curve for low threshold voltage device. So it has also shifted. So we can clearly observe the shift with the help of this image, so you can see that we have overlapped the two voltage transfer characteristics curves on a single image. Also here you can see that the slope of the drop is different. So here also the slope of this curve is different and the slope of this curve is different. So the output voltage will decrease, output voltage decreases at a different slope. Also we can see that at this point the difference is very minimum. So these are the comparison of the voltage transfer characteristic curves for the low threshold voltage device and high threshold voltage devices in VLSI design. So this is a very important concept, and by doing this experiment we could understand the basic differences between the low threshold voltage device and high threshold voltage device and their advantages and disadvantages. So thank you. Please like and share the video and subscribe the channel for more such interesting videos on VLSI design.